So last night I was tutoring one of my pre-calculus high school students on a sinusoidal word problem. Sinusoidal meaning those wavy functions that are represented by sine of x or cosine of x. And if you want to see what that looks like, you can go to desmos.com and type in y equals sine x or y equals cosine x to see what I mean. I was inspired to make this video about it, so let's check it out on my board. So the problem says a tire runs over a piece of gum and keeps moving at 30 revolutions per minute. If the diameter of the tire is 24 inches, how many seconds will pass until the gum has reached a height of 18 inches for the 9th time? One of the first things to identify is which sinusoidal function are you going to use? Is it going to be sine of x, cosine of x, tangent of x, some sort of inverse? We need to be able to identify that. And for the sake of time, we're going to be using a negative cosine function here. And I'll illustrate the reason why here. Let's start with the parent function, or like the original function of just f of x equals cosine of x. And I'm going to draw what that looks like here, just like that basic function here, where I have 1 up here, 0 at the axis, and then -1 at the bottom. And the period for these parent functions is 2 pi. And that can come in another explanation later, but I'm just going to put pi and 2 pi here to save time for the video. And with the original function, or that parent function of cosine x, we start at the top here, then go down to the bottom where -1 is and pi is, and then go right back up to 1 where 2 pi is. And it's going to look like a bowl, so it's going to go down to here and then go right back up. So I'll try to draw over this a little bit better so it can be a little more visible. And so we can see that's what that original parent function of cosine x looks like. Now, this is not going to work as is, because when we think of a tire, when we think of something, a tire running over something, it's going to start on the ground, then reach the top of the tire, and then go back down to the ground. And here, this is starting at the top and then going down and then going back up. So something that is a little more realistic is we're going to flip this upside down. And the way we're going to do that is we're going to use f of x equals negative cosine x. And when this looks like, and I'm going to draw this here, still have my 0, still have my 1 up here, still have my -1 down here, and then I have pi in the middle and 2 pi at the end to complete the period. And this is going to be the opposite. So this is going to be my top up here, and then this is going to be my bottom here and here. And then I'm just going to draw that curve up to show this is the peak, and then come back down. And I'm going to draw it over again, just to make it a little clearer. So now that's illustrating a little better what we're looking for, because like I said, the piece of gum starts at the bottom on the ground, reaches a peak at the top of the tire, and then goes back down to the ground before it goes back up again because it's rolling. But the problem with this is going below the x-axis, going into the negatives. And we're not starting below the ground, we're starting on the ground. And so what we need to do is take this and shift this up, so that way the bottom here, or the beginning of the period, starts at 0. And so that's going to look like this. F of x equals negative cosine x plus 1. So we're going to take all of these values and shift it up by 1. And that's going to look like this. So this time, I'm going to have 2 here because I go up from 1 to 2 at the peak. 1, and then also have -1 down here and 0 at the axis. Still have my pi and my 2 pi to complete the period. And so now that will look like this, where you go up to the peak and then come back down. And this parent function is what we're going to use, this version here, because it's realistic. We're not touching, or we're touching the ground at the beginning and the end, but we never go below the ground. So this is where we would start with creating that function or writing that function as it applies to the problem. Now let's customize or tailor our most recent iteration of the parent function to apply to the problem. So as you can see here, we start on the ground. That piece of gum is on the ground when the tire rolls over it. And then when it reaches the height of the tire, that's going to be at 24 inches. So right here, as it applies to the problem, will be 24 inches. And I'm just going to cross out this 2 here and put 24 to show that that's the height. Now, if this is going to be 24, then this 1 is going to be 12, and likewise the -1 will be -12. I don't have to do that, but we're just going to keep things consistent. So the amplitude of this. The amplitude here is going to be 12. And the reason how we know the amplitude is we're going to draw just this dotted line here showing like the mid-level of this sinusoidal function. As you can see in the earlier iterations of this parent function, the x-axis served as that median. Because this dotted line is now the new median or middle axis of this sinusoidal function, the amplitude here is going to be 12, or A equals 12. So again, we've shifted our function up by 12 and the amplitude is 12. So then that means that we can rewrite this function as f of x equals -12 cosine x plus 12. And there's one more item that we need to consider, and that is going to be the frequency, or a value that is going to go right in between the cosine and the x. And the way we're going to determine the frequency, or how fast or how tight this function goes up and down, is we're going to take 2 pi times the revolutions per minute. And 2 pi times 30 is 60 pi. And so now we have our full function as it relates to this problem. -12 times cosine, and then in parentheses, 60 pi x, close the parentheses, plus 12. Stay tuned for part 2.